We left off talking about the firm supply curve, and just as a recap, remember that the firm supply curve is the portion of the marginal cost curve above the shutdown point and the portion of the price axis below the shutdown point. One of the things that's important to recognize is that that portion of the supply curve that's along the marginal cost curve is upward sloping. This reflects what's known as the law of supply. And all this says is that as the market price of the good increases, the quantity supplied increases. So as price goes up, the optimal thing for the firm to do is to increase its output. By the same token, if price goes down, the optimal thing for the firm to do is to decrease its output. Unless, of course, the price falls below the shutdown point, in which case the optimal thing for them to do is to completely shut down their operations. Now, the firm supply curve is a useful device for us because it gives us some context to understand how firms make decisions with respect to output. The problem is we don't actually get to observe individual firms' outputs. That's not to say that we don't know that they exist. We do know that firms supply. It's just that the information that would be needed to try to estimate a firm supply curve is proprietary. That is, it's the firms, and they're probably not going to tell you much about it. However, we can actually measure supply at the market level. And this introduces the notion of a market supply curve. And this is simply the amount of a good that producers are willing and able to produce at various prices for that good. So it's the aggregation of all the supply of all the firms in that particular market. To illustrate how we get at a market supply curve, there's space on the top of page 10 for you to draw the following diagram. Now, the diagram that I am going to show you in a minute simply gets at how we derive a market supply curve. And this is simply the horizontal summation of the quantity supplied by individual firms at given levels in the market price. So at a particular price, firms will make a decision about how much to produce, and to get market supply at that price, we simply add up however much the firms are producing. Now, it's important to remember that we're dealing with the short run still. And it's typically the case that in the short run we assume that the number of firms is fixed. So to get at this notion and to see how we aggregate across firms to get at market demand, we're going to make some assumptions that may seem silly. We're going to assume that all firms are identical. Now, within a particular industry and within a particular size of firm, it may be that they're quite similar, and so this isn't quite as unrealistic an assumption as one might think. Comparing across different countries, this could actually have some problems because the technology that defines a firm in Canada might be different than the technology that defines a firm in Zimbabwe. Nonetheless, on the left-hand side, we have a supply curve for a firm, and this just simply shows the optimal level of output that a firm would produce at different levels of price. On the right-hand side, we have what will eventually become the market supply curve. You might want to take a few minutes to pause the video and actually draw this in the space provided on page 7. Now, what we're going to do is recognize that the market supply is simply the horizontal summation of the supply by each firm at a given price. So at the price P star, if there was only one firm in the market and that firm was producing Q1 star units of output, the supply curve for the market would actually correspond to something that looks like this, S1. And S1 is simply the firm supply curve. And as we increase price, we would increase the amount that the firm is producing, and we would have a corresponding increase in the market supply curve. If we had two firms like the firm on the left, the supply curve in the marketplace would look somewhat different. Instead of just having S1, we would add to it another firm just like it. And so what we would do is we would go off of S1 and add another supply curve to that, and we would end up with something that looked like S2. Now, the reason why S2 is a little bit shallower than S1 is that we've added another firm supply curve to S1, and so it sort of nudges it out further near the top than it does at the bottom, and that just reflects the fact that these supply curves have a slope. If we added a third firm, we would do the same thing. We would add that third firm to S2, and we would end up with a supply curve that looks like S3. And if we took this to its natural limit and we aggregated horizontally at a given level of price across all individual firm supply curve, we might end up with a market supply curve that looks like SM. And indeed, this is typically what we expect to observe in the marketplace. That is, the supply at the market level is much shallower than supply by an individual firm. Now, what is also true is that at P star, if individual firms are supplying little Q star on the left-hand side, that in the marketplace, the aggregate level of supply would be capital Q star. And that capital Q star is simply the sum of all individual firms' supplies at the price P star. Now, this notion of a market supply curve is actually really quite useful because, as I said, we can't observe individual firm supplies, but we can observe what firms collectively supply to the marketplace. Now, what we're looking for also is a way to try to capture how the quantity supplied in the market varies as the market price changes, right? Because the notion that we've been dealing with so far is that if you change the price that the individual firm takes, then it's going to change its level of output. But if all firms do that, then what we'd like to know is, okay, for a given price change, how does all of those firms' changes in their level of output translate into a change in the market level of output? And this gets at the notion of what an economist calls an elasticity, and in particular, the own price elasticity of supply. And all the own price elasticity of supply measures is the percent change in quantity supplied in a market given a percent change in price. On the bottom of page 7, there is a space for you to draw the diagram that's going to follow. This diagram shows a market supply curve. And really what we're trying to get at with the elasticity of supply is whether or not there's a very large change in quantity given a small price change, or a very small change in quantity given the same price change. And as I indicated, we're going to measure this with a ratio. And this ratio is simply the percent change in quantity supplied divided by the percent change in price, where we use the Greek letter epsilon to denote the elasticity of supply. Now, different authors will use different Greek letters to denote this elasticity of supply. I just happen to use the Greek letter epsilon, so it's important to pay attention to what others are using. We can actually characterize how quantity supplied reacts to a price change on two extreme ends, as well as several cases in between. On the top of page 8, there's space for you to draw 4 different diagrams that are going to look like this. You might want to pause the video and draw these figures, or at least the start of these figures, before you proceed. Now, as I said, there's 2 different extreme cases of elasticities of supply that we focus on. One is supply that's known as perfectly elastic, and the other is supply that's known as perfectly inelastic. If the supply curve at the market level, and indeed supply at the firm level, happen to look like this, there's a portion along the price axis that reflects where you wouldn't produce if price were below the shutdown point, but then the remaining part of the supply curve is a perfectly horizontal line, then we have what's called perfectly elastic supply. In these instances, prices won't change, and so the ratio of the denominator in the ratio that measures the elasticity of supply is actually equal to 0. If prices won't change in this instance, there would be no percent change in price, and so you're dividing the percent change in quantity by 0, and consequently the elasticity of supply is equal to infinity, because anything divided by 0 is equal to infinity. Now, this is a pretty extreme case, and it's not necessarily true that we think this is something that we observe in everyday life. A more realistic type of supply curve is one that looks something like this, one that is upward sloping but is relatively shallow. This type of a supply curve is known as imperfectly elastic. And the idea here is that if there's a 1% change in price, there's a very large percent change in quantity supply. So you can imagine moving a price value up a little bit along that price axis, and the level of output would increase quite dramatically as you increase the price. Now, because there's a large percent change increase in quantity given a percent change in price, it's actually the case that the elasticity of supply, while it's less than infinity, is also greater than 1. And all this says is that the percent change in quantity supplied is greater than the percent change in price when you have imperfectly elastic supply. Now, supply curves could be steeper in this. And in fact, in much of agriculture, we observe a supply curve that looks something like this. It's relatively steep. In fact, it's quite steep. We call it a supply curve that is very steep like this, imperfectly elastic. When you have imperfectly elastic supply, even for large changes in price and large percent changes in price, there's only small percent changes in quantity supplied. What that means is that the elasticity of supply is bound between 0 and 1. You do see some change in quantity supplied, but that change, the percent change in quantity supplied, is less than the percent change in price, and so the elasticity is less than 1. And then we can take this to another extreme case that we sometimes see in agriculture, and that's the case of perfectly inelastic supply. And that perfectly inelastic supply curve that I've just drawn is vertical. It's perfectly vertical. And what will happen there is no matter how much price changes, the quantity supplied will never change. It is fixed and it is set, and it will not change. In those instances, the elasticity of supply is equal to 0, because no matter how big the percent change in price is, there will be no percent change in quantity supplied. I'm going to go over these with some examples in class probably in a couple of days. And so if you're not entirely clear on it, look for those examples that are used to illustrate how we measure these elastic supply curves. And I'm also going to try to bring in some estimates of the elasticity of supply for different agricultural commodities throughout the world. Now, the other thing that we worry about when we're dealing with the supply curve is that we may not just get changes along a supply curve, that is, when the price of the good changes. We might actually get changes in the position of that supply curve. And there's a number of factors that might shift the supply curve either up or down. I'm not going to go into great detail here in the video, but in lecture, we'll talk about the different examples that we're going to illustrate and show you graphically how a change in some of these different factors will influence the position of the supply curve. Input prices are one factor that will shift the supply curve. And the idea here is that if the price of an input goes up, then that's going to change your cost structure. In fact, it's going to increase your costs, and that will shift the marginal cost curve up. If the marginal cost curve for a firm shifts up, then so too does the supply curve for that firm. And if you add up across all firms, what that means is that the market supply curve will shift up. So if the price of an input goes up, you're going to see an upward shift in the supply curve. Now, if you don't want to think about it as upwards, you might think about it as moving in the left direction. Technology is also a factor that can shift the position of the supply curve. And the reason for this is technological improvement changes the position of the total physical product curve and has an impact on the cost structure of the firm. And in fact, if you have technological improvements, that should shift the marginal cost for a firm down. And when that happens, if it happens for all firms, we'll see an outward shift in the market supply curve. That is, you'll see a shift to the right in the supply curve at the market level. The other factor that's important, especially in agriculture, is the price of other competing goods. So for instance, if you're thinking of planting a parcel of land to either soybeans or corn, you're going to look at the relative prices of them, and those relative prices might affect the crop to which you're going to plant. An increase in the price of soybeans, for example, would cause a farmer to grow less corn. What that would do is that would actually shift the supply curve for corn inward or to the left. Expectations about prices are also important. It's important to recognize that we don't actually know what the price will be when we start to produce some sort of an agricultural commodity. This is largely due to the biological lags in production. For instance, when you plant a field into corn, you don't necessarily know the price that you're going to get in a number of months. By the same token, if you're breeding animals for a herd expansion decision, you don't necessarily know the price of those fed steers that you're going to receive when you're making that breeding decision. But you're still going to make those decisions. Now that means you actually have to have some sort of a guess or an idea about what prices are going to be in the future. And this is where price expectations become important. And in fact, it's the case that producers will change the amount that they produce or market in the present term in order to take advantage of expected prices in the future. So for instance, if prices are low now, I might think that prices in the future are going to be high, and I'm going to act accordingly. That can shift the position of the supply curve. If you think prices are going to be high in the future, it's probably going to shift that supply curve out or to the right. Now lastly, I want to emphasize that the number of sellers is important in the position of the supply curve. When we derived the market supply curve previously, we assumed that the number of sellers or the number of firms was fixed. If you have more firms coming into an industry, the supply curve will shift outward. If, however, firms leave the industry, you're going to see that supply curve will shift inward. And the reason for that is that you're aggregating output across fewer firms. I want to finish off talking about decisions in the long run. Up till now, we've assumed that some firms have fixed inputs and that the number of firms is fixed. This needn't be the case, and indeed we could think about a long-run situation where all inputs are variable and the number of firms is allowed to vary. Now, when all inputs are allowed to vary, this changes the structure of the cost curve for the firm. In particular, there's no longer a total fixed cost. That's because all costs are variable. And so the total cost curve becomes the total variable cost curve. Now, when this happens, that changes the shutdown point. In particular, the shutdown point is now defined by the minimum point of the average total cost curve. If price is greater than the minimum of the average total cost, then the firm will continue to produce, and it will produce where price equals marginal cost. But if price is less than the minimum of average total cost, the firm would then choose to shut down. Page 10 of the notes illustrates a diagram that will look like this. I'll give you a few minutes to draw that, or you might want to pause the video to draw this. What I'm saying here is that we no longer have average variable cost. Now, that's not to say that we don't have average variable cost, it's just that all costs are variable. And so the average total cost curve is the one that defines the shutdown point in the long run. And in particular, the minimum of the average cost curve is the shutdown point for the firm in the long run. Now I'm going to stop there, and we'll pick up a discussion about entry, exit, and the long run, as well as profit maximizing choices of inputs.